Example, if you have a element which exists as a molecule, so you may have two peaks. Number one, it can be due to the molecule, or number two, it can be due to the atoms. Like example, if we say chlorine, so the chlorine is having two isotopes. Chlorine atomic number is 17 and atomic mass is 35. This is one isotope. Then there's another isotope of chlorine, which is atomic number 17 but atomic mass 37. So what happened when you use chlorine, but it's a group 7 element, and group 7 elements, how they exist on non-metal, they exist as a diatomic. So what are the possibilities? You may have a molecule, or you may have a, you might receive a molecule, or you, that molecule might dissociate into small atoms and then it will ionize. So if you receive chlorine molecule with a charge plus, or you may receive chloride ion with a plus charge. Then in chlorine molecule, there are three combinations, three possibilities are there. So in this chlorine molecule, the two chlorine atoms, maybe both of them are chlorine 35. The two atoms which are attached in a molecule form a molecule. Maybe both of them are chlorine 35. So if both of them are chlorine 35, so where you will get a peak, 35 plus 35, so you will get a peak at 70. Maybe one of the molecule is 35 and the other one is 37. So where you will get a peak, the sum 35 plus 37, you will get a peak at 72. And maybe both of them are 37. So where you will get a peak if both of them are 37, so you will get a peak at 74. So there are three peaks will be there. And you know the percentage of chlorine 35, which is 75%. And this is 25%. So you will get a peak at 70, 72, and 74. The peak of 70 will be higher because its percentage is more. Then peak of 72 will be there. And then at the last, there will be a peak at 74. So three peaks will be there, 70, 72, and 74. That's due to molecule. But maybe you will get a peak because of atom as well. So maybe this atom was 35, atomic mass 35, so you will get a peak at 35. Maybe this is 37, so you will get a peak at 37. And the percentage of 35 is 75%. So the peak which you will get at 35 will be higher. And the peak which you will get at 37 will be lower. So total number of the peaks which you will obtain for this chlorine molecule are not two peaks, it will be five peaks. Why there are five peaks? Two peaks are due to the atoms. These two peaks are due to the atom of the chlorine, and the remaining three peaks are due to the molecule of the chlorine. Is it clear? The peaks which you will obtain for a non-metal which exists as a molecule, then you will, the molecules giving three peaks and atoms are giving two peaks. Is it clear? Any doubt in this? So you can see here the mass spectra of chlorine molecule and bromine molecule. Why? When we obtain a mass spectrum of molecule, we'll get 3 peaks for chlorine and we'll get 3 peaks for bromine. And why the heights are different? This is about the molecule. Now the atoms will be there. We'll get a peak for atoms, but they're just discussing for molecule. So chlorine has 2 isotopes. One of the isotope is chlorine 35 and the other isotope is chlorine 37. So as we know, it's having 2 isotopes. So in the chlorine molecule, which is Cl2, it means maybe both of them are atomic mass 35. So if both of them have atomic mass 35, so where we'll get a peak 35 plus 35, so we'll get a peak at 70. And this peak will be higher. Why this peak is higher? Because 75% this and 75% other one. So when they join together, 75 plus 75, so total will be 150. That's why you will get about 150 in terms of percentage, in terms of height. Then if in a chlorine molecule, if both of them, if one of them is 35 and the other one is 37, so 35 and 37, so where you will get a peak, you will get a peak at 72. And one of them having a percentage of 75, another one is 25, so 75% plus 25, so the second peak you will obtain at 100. And the third one, if one is 75, 37 and another one is also 37, so this is 25 75 25%, the other one is also 25%, so you will get peak approximately at 50%. So you'll get 3 peaks and the peaks will be different in heights. Is it clear, the idea? Then same way it is happened for bromine. Bromine having 2 isotopes, one is 79, another one is 81. So maybe you will get a peak because of both isotopes have 79. So 79 plus 79, 158. Maybe you will get a peak due to 79, 81 or 81, 79. So that peak will be 160. Or maybe both are 81 and 81. So you will get a peak at 162. So why there are 3 peaks? Because maybe the combination of the atoms which are present, they have different atomic mass. This result in a different peaks. So you have to learn this mass spectrum for chlorine and for bromine. Then what are the uses of the mass spectrometer? Where we use this mass spectrometer? A mass spectrometer can be used to identify or find the like elements which are present or the number of the isotopes? Now some questions I'll discuss with you related to mass spectrometer. Just a minute. So these are the questions related to mass spectrometer. Already we discussed few of them. Like we discussed this one, how to get the percentage relative atomic mass. So 85, this was 72%, and this is 87, which was 28%. So 72 multiplied by 85 plus 28 multiplied by 87 divided by 100. So we got the relative atomic mass of this sample. Same way for this question, the percentage, this mass is 69, percentage is 60%, and the mass is 71, and the percentage is 40%. So when you solve this question, it will be 60 multiplied by 69 plus 40 multiplied by 71. Okay, this is 71 divided by 100. So it's 69.8, which is B is the right answer. That's correct. B. Then you can see we discussed this in the beginning of the class. Proton relative mass of a proton is 1, neutron 1, electron is 1 divided by 1840 or 1800, you can say. Relative charge plus 1, 0, minus 1. Then in terms of subatomic particle, what is the term isotope? Atoms with the same proton number but different neutron number are refers to isotopes. Then element rubidium exists as 85 and 87. Explain how a gaseous atom of a rubidium are ionized in the mass spectrometer. So what happened, how you write this answer? So by using a fast moving electrons, target the sample to knock out electrons from the shell. Then in the next question, in a sample of a rubidium, isotope 85 has an abundance 2.5 times greater than 87. Means when you compare the ratio, the rubidium 85 is 2.5 times more than 87. Calculate the relative atomic mass. So how you can calculate this? So rubidium 85 is 2.5 times higher. So this is 2.5 and into 85 plus 1 into 87. Why? Because when you compare, if this was 1, this will be 2.5 times higher. Divided by, what is the sum? So 2.5 plus 1, so that's equal to 3.5. Because if percentages were given, we used to divide with the sum of the percentage. But in this case, we have the ratio. So we divide by the sum of the ratio. So what's the answer? 2.5 into 85 plus 87 into 1, and this divided by 3.5. So 85.57 or 85.6. Write two decimal places for accurate answer, but 85.57, that's three significant figure. Your mostly answer should be in three significant, but in this case the mass spectrometer can record to more than three decimal places. That's why it is also a right answer. Is it clear? Discussion. Okay, so I'll end the session and share the recording with you. And I'll share this assignment as well and mention a date of submission. We did not complete the whole topic too. We just started the topic, the mass spectrometer. But after completing certain topic, I will discuss the question related to that topic so you have a better understanding of this topics. Any question related to the class today? Topic 1 assignment I will send now on the group.